Alright, so for 55 through 62, we're going to graph piecewise functions. So 55 is on the screen right now. This one is separated into two sections. The boundary line is x equals 0. So I'll go ahead and draw that in. I'll use a different color and I'll use a dotted line. So it's a dashed line, so it's going to go down the y-axis. Okay, and so for all x less than 0, we're going to plot this. So on the left side, we're going to plot 2x plus 3. And on the right side of the green line, we're going to plot 3 minus x. So we replace the x with 0 in the first piece. So 2 times 0 plus 3 gives you 3. So on the point 0, 3, I'll use pink for that, we're going to draw an open dot. Okay, and why open? Because it says x is less than 0. It cannot equal 0. So we show that by drawing an open dot. It's big enough, right? So 0, 3. And the slope of the line is 2, right? So I could either go up 2 to right 1, but in this case I can't, because then that would be going into the right side, which, you know, I have to stay on the left side for this piece. So then I'm going to go down 2, left 1. So I have a dot right here. And then down 2, left 1 right here if you want another one. And then just connect your points. Okay, I missed that middle one, but it's like I think I mentioned before, with us it's hard to control the stylus to draw like really nice straight lines and go through the points and stuff. So, but it should go through that dot. Okay, so that's the left side. The other side, 3 minus x, replace the x with a 0. So 3 minus 0 is 0. Now this one is a closed dot. So what happens, and I'll use a different color so that it stands out. What happens is that open dot gets filled in. Okay, and so there. And then the slope is negative 1. So that means I'm going to go down 1, right 1. Down 1, right 1, down 1, right 1. And just connect your points. And there's a graph. Okay, so the graph of f of x is a combination of the pink and the blue together. Okay, so 56, the boundary line is at x equals negative 4. So again, I'm going to go ahead and draw in a dashed line down x equals negative 4 to separate the two regions. Okay, so to the left of that green line, I'm going to graph x plus 6. And to the right of that green line, I'm going to graph 3x minus 4. Okay, because that's what the domain right here tells me. Okay, so replace the x with negative 4 on the first one up here. So if I plug in a negative 4 right here, I get negative 4 plus 6, which is 2. So 2, negative 4, 2 is the point. Negative 4, 2. Now it's going to be a closed dot because it's equal to negative 4. And the slope is 1. So it's going to go, I could either go up 1, right 1, but I can't on this one because I can't go over to the right side. I have to stay on the left. So I'm going to go down 1, right, down 1, left 1, sorry. And so you connect, should be more, oops, should be more like this. Okay? And then the other one, replace the x with a negative 4. You get 3 times negative 4 is negative 12, minus 4 is negative 16. So down here at negative 4, negative 16, it's going to be an open dot, and the slope is 3. So, or you could think of it as a y-intercept being negative 4, and just, you know, do a point there, and then connect the two. And there's a graph. Okay? So these two, the pink and the blue, both together make up f of x. Alright, so 57, I've got, again, two regions or two sections that I'm going to divide the plane into. the line that's going to divide them is the line x equals 0. So again, I use a dotted line down the y-axis for x equals 0. So to the left of this dotted line, of the green line, I'm going to graph this function because it tells me that x is less than 0. And to the right of the green line, I'm going to graph this function because it tells me that x is greater than or equal to 0. So I'm going to replace the x with 0 in the first piece. So 4 plus 0 is 4, and the square root of 4 is 2. So 0, 2 is going to be an open dot. And then I'm going to go to the left. Now, even though it says x is less than 0, and you usually think, oh, I can go on forever to the left, this particular function has a restriction. So the smallest x value I can use is -4. Because anything less than -4 would give me a negative inside the radical. So negative, if I replace x with -4, I get 0. So -4 is 0, and it ends up being a function that looks like this. Okay? For the other piece, the square root of 4 minus x, again I replace the x with 0. 4 minus 0 is 4, square root of 4 is 2. So the open dot, I fill it in with the closed dot, okay, because it says x is greater than or equal to 0. And just like in the previous section, you know, in the other piece, this says x is greater than or equal to 0, but I can't really go beyond a certain number because of the function that they gave us. So the biggest number I can use here is 4. If I choose a number bigger than 4, then I no longer have a real number, because then I'll have a negative inside the square root. Okay, so 4 is my biggest value, okay, for x. So 4 minus 4 is 0. And then it's a curve kind of like that. Okay, so there's the graph. Alright, so 58, the boundary line is at x equals 2. And so just like on the previous problems, I'm going to divide the regions with a dotted line. So x equals 2 goes somewhere around here. I'm trying to be as precise as possible, but anyway. So to the left of x equals 2, I'm going to graph this parabola. And to the right of x equals 2, I'm going to graph this square root function. Okay? So just like before, we're going to replace the x with a 2. So you put in the 2 right here. So 2 minus 1 is 1. We square the 1 and we get 1. So 1 minus 1. This one minus the 1 here that we get is 0. So the point is 2, 0. And it's a closed dot because it says equal to 2. So 2, 0. Now, because it's a square, I know it's a parabola, right? So the vertex is 1, 1. And how I know that is because this is my h value right here, and this is my k value. So 1, 1. So I know that the point vertex is here. And I know it opens down because of the negative in front of the parentheses. Okay, so if x were 0, just to get another point, you get -1 squared, which is 1, 1 minus 1, 0. So it goes like that. Okay, so there's your parabola, or piece of a parabola. And then for the square root of x minus 2, we replace the x with a 2, so that's going to give us 0. It's an open dot, but it doesn't really matter. I mean, I'll show an open dot, but it's closed anyway, so it's open dot. Whoops, disappear. And then greater than 2, so if x was 3, let's say, I'd get 3 minus 2 is 1, square root of 1. So something like that. Okay, so 59 is a piecewise function that has 3 sections, 3 regions, 3 different functions define it, and the boundary lines are at 0 and 2, at x equals 0 and x equals 2. And how do I know that? Because I look at the domain. And there's a cut at 0, and then there's a cut at 2. So I'm going to show that on the graph by drawing the dotted vertical lines, one on x equals 0. And again, remember, like I told you in class, this is just to remind you that each function, each piece of the function has to stay in its own region. Okay, so that drawing the lines there will help you keep every piece in its right place. Okay, so for x plus 3, that's going to go here on this side. The line y equals 3 is going to go, or the segment is going to go here in this middle section because it's between 0 and 2. And then the 2x minus 1 is going to go over here on this side. Okay, so let's go in order. Let's start with the top piece. So replace the x with a 0 and you get 0 plus 3, which is 3, and it's going to be a closed dot. So 0, 3. The slope is 1. So since I can't do up 1, right 1, because then that would put me in the wrong region, I've got to do down 1, left 1. So I'm going to go down 1, left 1, and then connect and draw the ray. Okay. So for the middle one, the 3, that's from 0 to 2. Open on 0, closed on 2. So it's going to go like that. It's a horizontal line. And then for the other piece, let's change the color. The third piece, 2x minus 1, replace the x with a 2. So 2 times 2 is 4. 4 minus 1 is 3. So that would be open there. And then the slope is 2, so then that means it's going to go up to right 1. Like that. It didn't come out quite like a line or a segment, but it's crooked. Sorry, but let me see if I could fix it. Okay, this way, and that's it. Alright, so number 60 is another graph that's divided into 3 sections. The boundary lines are going to be at x equals -3, because again, that's where there's a break, and then x equals 1. There's the other break. So at x equals -3, I'm going to draw a dashed line. And then at x equals 1. Okay, so for x plus 5, this piece of the function up here, I'm going to be graphing that on this side, because that's where x is less than or equal to -3, sorry. The line y equals 5 is going to be graphed in this middle section. And then 5x minus 4 is going to be over here on this side, on the right side. Okay, so let's start with x plus 5. So if x is -3, -3 plus 5 is 2. So -3, 2. And it's going to be a closed dot. Now the slope is 1. So since I can't do up 1, right 1, I'm going to go down 1, left 1. So I'll end up there. And then the middle section, between -3 and 1, it's going to be the line y equals 5. And they're both open. Oops, missed it a little bit. There, they're both open. The two endpoints are open. And then for the last one, 5x minus 4, I'm going to plug in a 1. So 5 times 1 is 5, minus 4 is 1. So the point is going to be 1, 1. So 1, 1. And it's going to be closed. And the slope is 5, so it's a very steep line. It's going to be about here. Right there. So there you have number 60. Okay, three pieces make up the function. Okay, for 61, we're back to 2 regions, 2 different